Hi everyone. Last video we showed how to construct a GeoGebra file for the walking pattern like this. So today I'm gonna also show how to construct the SolidWorks model just based on the static model and dynamic model we get from GeoGebra. Okay, so before we do this, I just uploaded the newest version of the SolidWorks templates. So make sure you guys download these SolidWorks templates because we're gonna use those templates to build the SolidWorks model. And let's go to the templates directly. So it's right here like this. I've already downloaded the files and so I can just open it. So when you guys downloaded the files and open the folder, it will be something like this. It should be exactly the same. So um, we have the base and we have those parts. And basically those parts are pretty much the same with what we use for the Halloween walker. So I just added um, some links we will use for this walking pattern, and I changed some length of the link. For the hubs, hardware, and gears, I didn't change anything. So because I've already changed the parameters of the links, make sure you guys will do the same when you do your homework. So I'm gonna show you what I did for those things. So you can see from the sketch, we have all the geometric of the link, right? Like the size of the holes and the length of each side of this link. So I have changed those length according to the GeoGebra model I get from here. For example, this is the ternary link, which will be this brown link right here. And you can see, for example, this red side is 6.912, okay? In GeoGebra, on the left, you can see the length. And here, so I change the length to be the same with the same side of the length. See, it's 6.912, and this side also 6.912. And make sure when you change the length, it is the side you want to change. For example, this side is the opposite side of the foot, like here. So the foot is here, the opposite side of the foot is this side, and the length is like this. You will see there will be a little bit difference between those two triangle links, but just don't worry, you can use the same one. Or because you will need to build two ternary links anyway, you can change this length, but I just keep it the same because I think I think it's okay if you keep it the same. So yeah, so the length opposite to the foot is 6.912, and I just did it like this. And make sure you change all the length like what I did here. For the size of the holes, I think it's okay. And I don't think you guys need to change it unless you want to use the screws that are not provided in the templates. Or if you need, just change the size. It's okay. It's also like go into the sketch, double click the sketch, and then you can change the size of it. Anything. Okay, so make sure you guys change the size, the geometry in those parts, and I'm gonna show you right now. I'm gonna show you what I did for this walking pattern and what is the target for this video. So we're gonna build something like this. Ooh, rebuild it. Okay. Wait, what? Let me open it again. I don't know why there's some glitches on my computer. Okay, so we're gonna build something like this after this video. And you can see this walking pattern is exactly the same thing with what we did in the GeoGebra. So the input link will be fully rotated, and the output crank is these two brown cranks. So yeah, um, let's get started for this walking pattern building. Okay, first we need to create a new assembly file. So click the new SolidWorks document and then choose this assembly. Click OK. Then we're gonna insert the first part where we need to insert in this assembly. So go to the template and then click the base. So the first one is always the base because the first part uh, that was inserted to the assembly will be fixed by default in SolidWorks. So we're gonna choose this, open, and you can see you can drag this base anywhere you want, but a better way to do it is just go to this check mark on the left, then click OK. So this will make sure this base part will be at the center of the origin, like this. So this origin will be at the center of the base, sorry. And in this way, you can locate the part you just inserted, so you can find it. It will not go like somewhere you cannot find it. And then let me see. My preference is insert the other links we're gonna use next. So the binary link, we're gonna use it, and we're gonna use two binary links, right? So from the GeoGebra, we have two binary links, two blue links. So we're gonna insert again, or another way to do it is you can drag from the part list directly. So push your control button and then push your left button on your mouse and then just drag it like this. Okay, and then we need the crank. Okay, let me open this. So for the crank, we'll need two cranks, input cranks. That is because we want to avoid the interferences between two legs. So insert this again, and then we need two ternary links. We will have two versions of this ternary link, but actually the length of the side are the same. The only difference is the size of the holes. You can see we have larger holes for this one. This is because one of those ternary links are gonna connect it with this input link, and we were gonna use a hub right here. So we need one with a larger size, like this. Then next step, so since this one is gonna connect it to a gear, and then the gear is gonna connect it to the motor, so we will need the bearing right here as well. So I'm gonna insert the bearing. Here, I think the bearing we're gonna use is the this one, 1/4 inch ball bearing. Should be this one. And that goes to here. Okay, that looks good. Let me double check. Okay, so this is 0.5 inch, and this is also 0.5 inch as well. Okay, what I'm gonna do next is to mate with a hinge mate. So go to this, um, should be mechanical, and here the hinge mate. So those two faces are this one and this one, and we're gonna mate with this surface and this surface. Okay, flip it. Okay, this is what we want. And then we're gonna insert the hub, but let me see. Oh yeah, before the hub, we're gonna use the spacer, I think. So insert the spacer. I believe the spacer we're gonna use is this, spacer 2 mm. If the size of the spacer is not what you want, then you can always change the the thickness of the spacer. So again, use the hinge mate, do the mate, then mechanical hinge, this surface, the bearing, this surface, and let me see. It's actually will go to this surface like this. Okay. And then we're gonna insert a new hub. So this hub should be this one, 1/4 inch hub. Okay. And this hub will go to the input crank. So I'm gonna put it here, pull the input crank, and then do a concentric mate between the hub and also the input crank. Oh, actually no. Uh, Let me do also a hinge mate. Okay. And this surface go to and goes to here. Flip it. Okay, well it will do like this. Okay, looks good. And then let me see. Okay, another hinge mate to connect this spacer and this part. Then this surface goes to this surface. Okay, looks good. Okay, the input link will go like this. Then we need to attach another hub to this input link. Okay, so insert a new 1/4 inch hub and then do the hinge mate again. Flip it. Okay. This hole and this hole. So for this one, we can make it concentric, but this will break our hinge mate, I think. So we can also do this tangent, this hole and this hole, just to make sure these two holes are in the same position. Also, we're gonna do this hole with this hole. This one we can do concentric. I don't know why, but if you can do concentric, you just do concentric. But if you cannot, just do tangent. So let me double check with the mates. Okay, that looks good. Okay, and then the other thing we need to do is basically just like here. So we need another spacer that attached to this hub. So I'm gonna insert a new spacer, or I can drag it from the left. The spacer is here. Okay. Drag the spacer and then do the hinge mate again. This hole to this hole and this surface. Oh wait, hinge mate. This surface to cannot do this. Let me redo it. This is because the spacer goes into the hub, so I cannot choose the surface I want. Okay, let me drag the spacer out. Then do the hinge mate. This one, this one, this surface, and this surface. Flip it. Click OK. To continue with this part, um, we need to assemble this turner link to this joint, right? So what we need to do next is to put something on this one. So as you can see from the GeoGebra model, this joint, this input link is connected to this turner link by this joint. So the reason I choose the turner link with this larger hole is because this one will be connected to the hub. So that's why I choose this one instead of this one with two small holes. Okay, let me insert another spacer. Okay, make sure, yes. Hard wheel, spacer. We're gonna use the 1 mm spacer for this joint. So I'm gonna do the hinge mate again. Okay, like this. And then copy this spacer, do the hinge mate. Oh, wait. This surface to this surface. Okay, looks good. Okay. And then we're gonna put the bearings for this hole. So the bearings we're gonna put is this 1/4" ball bearings. This is because the size of this hole can see it's 0.5, and the spacer is also 0.51. The size for the spacer is a little bit larger than what we need, is because the spacer will be 3D printed. If we're gonna manufacture this model, the spacer will be 3D printed. So the actual size we get from the 3D printer will smaller than what we design. So again, do the hinge mate for the bearings. This goes to here. This surface with this surface. Okay, looks good. Then use this bearing again. Do the hinge mate. Flip it. The reason I redo this hinge mate is because the side of this turner link actually matters. So cannot do just like this. So what I need to do is I need to make this surface. So click this to here, do a hinge mate, and then this surface goes to this spacer. Wait, so actually let me do this. This surface goes to this spacer first. Flip it. Okay, looks good. And then here, this one, go to here. Okay, so this is what we want. Because we want this joint go to the right, so that's why we need to make this joint like this. And probably the hinge mate will not work for this one, is because um, it's gonna be do it's gonna do a fully rotate for this ternary link. So SolidWorks cannot calculate in this way in a hinge mate. So what you need to do is to do this coincident mate first, and then do the concentric mate. Okay, and then let me finish this joint. We need another 2 mm spacer on this surface. So I'm gonna drag it and then do the hinge mate. This one we can do the hinge mate. This thin surface to this surface. Okay, looks good. And okay, let me think. We will need another hub attached to this spacer. So let me get another hub for this. Then again, hinge mate. this surface is attached to here. Flip it. Click OK. And then the hinge made between this hub and this input link. This one, this one. And this surface goes to this surface. Okay, upside down. Click OK. Okay, let me do this. So let's keep this way. Mate this hole with this hole. Okay, and then mate this small hole with this hole. Use tangent. That should work. Okay. All right. And then the right side with this hubs are pretty much finished. So next step will be attach those links. The next step will be attach the right binary link to here, like connect this joint and this joint. So first we can see we have the smaller hole on the on the base and a bigger hole on this turner link. So that means we should put two bearings on this turner link. Okay, so let me insert and then go to, it should be this one. Okay, that is correct. Hardware 3 mm ball bearing. So this one, okay, let me open this. And we're gonna do the hinge mate again. Okay, that looks good. And then just drag this, then do the same thing. Oh wait, should flip it. Okay, and here we're gonna attach a 1/4" spacer. Oh, we need to attach a washer first. So washer, is it this one or let me see. Oh right, it's this one. So the washer starting with the number. This is what we want. Open this. And then hinge mate again. So the hinge mate is a little bit annoying because but it will be useful when you do the motion analysis because it will reduce the number of the mate. This surface to this surface doesn't matter. Can do the flip. Okay, great. And then we're gonna use another spacer. So the spacer with quarter inch, I believe it's this one. Okay, that looks good. And then this link will go to here. Also hinge mate. This surface goes to this surface. Okay. And at this joint, you can see also we got a large size, right? So which means we need to put the bearings. Actually, let me try if I can copy this part. Oh, so I cannot. This is because I used the hinge mate. All right. Then I just drag it from the part list. Then do the hinge mate again. Okay. Um, so we're gonna need to make this joint to here. We're gonna use for positioning only for now because I don't want to add some useless mate. Then we can try to play it a little bit. Okay, that looks good. And then the next step is to have something right here. So we're gonna need a washer again because we have a spacer and then this spacer will attach to another. We have a bearing and this bearing will attach to another spacer. So insert the washer, hardware, then here. Okay, steel washer. Yes. Oh, it happened again. So I will just pull out from the part list. Then do the hinge mate. with this side. Okay. And then we can measure the distance between this surface and this surface. So if we choose these two surfaces at the same time, you should be able to see the distance right here. It's around 0.31 inches, right? And I think we have this spacer directly, so you can use it right here. So make sure the spacer is the exact distance. So if it's not, you can always change the length, the thickness of the spacer. It's 7.936 millimeters. Actually, let's keep it for this prototype because that actually won't influence that much. Okay, let me see. We're gonna do the hinge mate again. This hole to the washer, then this surface to here. Click OK, and then what you need to do is make this hole with this hole. Here you're gonna do a concentric. Okay, that looks good. Let me try to rotate it. So you see, the reason why we have these two layers is because the input link will do a fully rotate, right? So if you have only one layer and you will have another leg on the same layer, then those two legs will have interferences. That's why we do two layers of the input links. So this is the right leg, and next I'm gonna do the left side. So this hole will connect with let me see. Will connect with this hole, I think, right? And let's see. Actually, first let me put the bearings into those two holes first. So drag 4 bearings and then do the hinge mate. This one go to this hole, this surface with this surface. Okay. This one also goes into this one. Then, oh, it's the hinge. Hinge mate. This one to this one. Flip it. Click OK. This one go to this. Then the surface will also be the same. Okay. This one go to here as well. And this surface will make like this and flip it. Okay, let's see. So I'm thinking if I should connect this joint or this joint actually. Let me see. So let me double check with the GeoGebra. The joint that connect with this input link is 8.6321. 8.6321, okay? Oh, so it's the longest one. The longest one go to the input link. Okay, got it. 7.7, 6.9. Yes, the longest one. Okay, so here this is the longest one, which means this joint should go to here. Okay, before I do this, let me put a spacer first. So I need another 1/4 inch spacer right here. Then again, hinge mate this hole with this hole, this surface with this surface. Okay, that looks good. And then I need so I will need a washer. Yeah, I will need a washer on this side. Okay, let me pull up a washer. Then do the hinge mate again. Okay, that looks good. And then we will do the hinge mate for the washer and the spacer. This surface will attach to this surface. Okay, it will becomes like this. All right, this is what we want. Then last thing is this joint. So here we have the bearings, so which means this one will attach to the smaller hole size will attach to here. The one we have already have bearings. It will be the same thing. So the layer should stay the same, which means it will goes from the washer to the spacer. Okay. Then do the hinge mate again. So here we need to do the washer first. Actually, let me do this way. So it's gonna be easier. This surface is attached to the washer. Click OK, and then do the hinge mate again with the washer and the spacer. Okay. Then we can do the hinge mate between the spacer and the link. Right here. Okay, looks good. Whoa. And then we can do the same thing. We can mate this hole with this hole first, just for positioning, right? Because I don't want to like add more useless mates. So you can see this is pretty much what we want, right? And then what we will need to add is the same thing, just like here. So we'll add the spacer first. No, actually, let me add the bearings first. So the bearings, okay, we need two more bearings right here. Okay, then do the hinge mate. Okay, that looks good. And then the washer. Drag the washer out. Hinge mate. Okay, that looks good. And then again, measure the distance with the base and the washer. So this surface and this surface. It's like 37.629 millimeters or 1.48 inches. I believe also we have this part, so you can use it directly. Should be this one. Okay. Hard wheel. Yes, right here. 1.48 inches. So use this. And then just do the hinge mate again. So I'm gonna do the hinge mate with the base this time. It should be the same. This surface attached to this surface. Okay. And then last thing is this one with this one can be concentric. It doesn't have to be the hinge mate. Can be concentric because the distance is already measured, so it doesn't matter. Okay, let me try this structure right now. Okay, that looks great. And one last step is to have the motor and gears on this side, and also we're missing the screws right now. Okay, let's do the motor part first. So for the motor, we need to insert some components first. So choose the insert components and then electronics. What we need is this motor and also the motor bracket. So open this, put it on the side, and then we will need the gears. So choose the gear and then copy it by push the control button and then drag it. Also, let me see. We will need the hubs. So, and we need those two hubs at the same time. This 6 mm hub is for the motor, and this 1/4 inch hub is for the D shaft. So pull it on the side as well. Then we can start to mate all these components. Okay, let me see. So we're gonna mate the motor with the bracket first, and we can choose the hinge mate again. So this uh, downside downside of this cylinder surface, mate this with here, and then the surface, of course, is the motor, the front surface of the motor, and the back surface of the bracket. So it's gonna be like this. And after you do this, you will see actually the small holes on the bracket and motor are lined up automatically. So you don't need to like do the concentric mate for these holes. And then we need to find out which hub is for the motor. I think it's this one. Yeah. So as I said, you can always check the diameter, the size of the surface on the bottom right here. So right now it's 3 mm, and the radius of our motor is also 3 mm. So we're gonna use this one. And again, we use the hinge mate. Okay, select this surface and this surface. Okay, so for the plate uh, plate surface on the bottom side, we're gonna need this small surface here, and then again the back side of the hub. Okay, looks good. And we need to line up those holes, right? Because this is not lined up right now. So we're gonna choose the hole and choose concentric. And then, oh wait, we're not doing this for now. Um, what we need to do is to mate the hinge mate, mate the gears with the hub for now. Okay. Let's see, here goes here. This surface go to this surface. Flip it. Okay, that looks good. And then we're gonna line up the holes. So choose this hole and mate with this concentric. Okay. Okay, that part looks good. Then we need to line those gears to the base. So what we need to do is we don't have any construction lines for now, right? Because we don't know like where we should line those gears. So I'm gonna draw this construction line first. So open this in position and then choose this normal tool. So this is where we're gonna put the crank, right? And I'm gonna choose this sketch, choose this surface, and then choose the circle. So from this point, draw a circle and then draw another circle on the left probably. You can see, well, let me do this. So go back and then add a center line just to make sure this is horizontal. And then from this point, I draw another circle. So you can see those two circles and also the distance are random. And what I need to do is to make sure the size of this circle is equal to the size of the gear. So we can go to the file and you can see the gear is 2.5 module and 15 teeth, right? So the radius, oh wait, um, the diameter of the gear should be the modulus times the number of teeth, right? So what I'm gonna do is put a smart dimension and then use 2.5 times 15. Make sure the unit is millimeters. So click OK. Okay, so we have one circle. And for this one, we can push the control button and select this circle. Also select this circle. We have some relations on the left, right? So add this equal. And then we will need these two circles to be tangent because the gear should be made, right? So we choose this tangent again. Click OK, and we can check like this. Okay, so this is what we need for now. And then we can select all the things we draw just now and click this for construction. Okay, and then exit. Save the file, exit again. Choose yes. Okay, now we know the position, like where we should make the gears. So I'm gonna do this for now. Um, we can choose the cylinder surface of the gear, choose mate, and then choose the trajectory we just drawn. Okay, like this. For this one, it will be the same. Choose this surface, choose this cylinder. Okay, so you see these two gears are not lined up, like they're not on the same surface, right? So we need to add one more gear to make sure these two surfaces are the same. Okay, yeah, we have them now. Okay, that looks good. Actually, let me check one more thing. I think I probably didn't do it correctly for the motor mate. Let me double check with it. So these two surfaces, I should probably choose the upper surface right here. Let me redo it. So let me delete this one and go to here. Um, yeah, let's do it this way. So choose OK, and then we need to line up those holes. So let me think. This one, wait, this one should go to here. No, should go to here. Okay, that looks good. And then the other thing I need to do is line this one. Wait, let me add another mate parallel to this surface. Okay, that looks right. Actually, we don't need this hub probably. Let's delete it for now. Okay, that looks right. The reason I put it upside down is because you see the space for the motor is not enough actually. So if you want to put another base for the motor and then use the nut strip to fix the motor to hold it, then you will not be able to do it. The way I just mount the motor, you can only do the base on the upper position right here. Actually, we can also do it. So let me adjust this. Okay, delete, and then go to the upper side. So it will do like this. Okay, that looks good. Then go to here. And then we need to make the gears. So we can go to normal to this surface. And then you see, you cannot really see the gears, right? So it's better if you can hide this component first, hide this motor, choose this one and click hide component. And also hide this one as well. Okay, that looks better. So those two are not made right now. You can align it to the right position. Like you can see this is a very good position because there are some spaces between two teeth and it's also a good mate between those two gears. So what I need to do is use mate and then mechanical gear. I usually use the inner surface of the gear to mate. And then this ratio we can say 1 by 1. Okay. And click OK. And then we need to bring the components back. The components we just hide it. So unhide this one, unhide this one. Then we can try to rotate the gears. Okay, goes to the back side and normal to, then rotate. Okay, that looks good. And now we're missing the D shaft that transfer the motion energy from the motor to our links. So yeah, we still need the hub. Okay, let me insert this hub first, and then we will need the D shaft. So I think the length we need is this 1.375 inches long. So choose this and then choose here. Okay, I'm gonna mate this hub first. So use mechanical mate, hinge mate. Then this two circle this surface with this surface with this surface. Okay, great. And then I'm gonna mate, oh no, not this surface. It should be the cylinder surface of the D shaft. So select this one and select uh, this, this bearing. So do a concentric. Okay. And then next, we're gonna fix the distance from the gears to the base. So let's see. We have this concentric mate, and then I think we need to fix this one to this surface first. Coincident. Okay, click OK. So it's gonna be like this, right? And then let's see. Then we can do this surface made with this one. Also coincident. Okay, that looks great. So we fixed the distance of the gear. Okay, right now let's try if we can rotate this one. Okay, yes we can. Oh yeah, I didn't line up the holes, so let me line up this for now. Okay, that looks good. Okay, and let's try rotate it. Okay, that looks perfect. Um, let me see. So when you manufacture the real prototype of anything you build, just make sure you line up the holes like more strictly, because right now you see the screw of the hub is right here in this position. However, it should be perpendicular to this surface, but for the theoretical model, which is in the SolidWorks, it should be fine. So if you didn't line up those two things, it's okay. But I mean, in the manufacturing process, it is necessary to to have the screw to this flat um, flat surface. So actually, for now, this model is ready to do the motion analysis. But if you guys want a more completed model in SolidWorks, so you can see we're missing one thing, which is the base for the motor. So I can do it for now. Okay, let's create a new part and then just choose front plane and then draw a rectangle. Let's choose this. So draw a rectangle and then choose this smart dimension. The width can be, let's see. I think the length of the nut strip is 2.2 inches. And then for the length, we can do 5 inches probably. Okay, something like this. Okay, and then choose this sketch, choose features, and then do the extruded boss. Okay, the thickness is gonna be 6 millimeters because this is the wood we're gonna use for the project. Okay, and then let's save it to the correct folder. So let's call it motor base. Save. Then exit. Then we need to insert the motor base we just created. Okay, rotate it a little bit. And then we need a nut strip. Should be in the hardware. No, not this one. Here. M3 nut strip. Okay. I want to copy the color of the wood. So here's how I'm gonna do it. Copy appearance and then paste. So choose the body. Okay. And then we can mate the nut strip with the motor base first. So it's pretty easy. Mate this surface with this one. Click OK, and then make this surface with this one. Click OK. Make this surface with this surface. Click OK. Okay, that's pretty much it. Okay, let's save the file for now. And then let's continue. So we want this motor base to be attached to the base we're building. So we're gonna do like this. And then you can see we can move around like so. It's attached to the base right now. Let me show the normal to this surface. So you can see I cannot drag it from left to right or like horizontally, but it's still moving, right? And what we need to do is we're gonna make this surface to here. And now it's attached to the motor, but it's still not centered, right? So we'll need this width mate, and we choose these two sides, also two sides for the base we're using. So it's gonna be centered like this. Okay, that's what we want. And now we need to drill the holes for the nut strip because we want to fix those three parts, right? Oh, the base, the motor base, the big base, and also the nut strip. So here's how I'm gonna do it. So normal to this surface, and then we can hide this sketch for now because this is not necessary. Those are just for we fix the position of the gears. So we can just edit this sketch directly. And you can see we have the positions of the holes, right? So we just need to draw the holes to here. And actually, let me do M3. So a little bit smaller than the holes on the nut strip. Okay, 4 holes, and then choose 3 millimeter. Wait, 1.5 millimeters for one. Okay, so this is 1.5 millimeters, and then select all of them, choose equal. Okay, and then use smart dimension to fix it. Okay, the diameter should be 3 millimeters. Okay, that looks good. And then exit. So see, we have the holes for the base. Okay, that looks good. And then we will need to drill the holes for the motor base. So 2 sets basically. I mean normal to this surface again, and then add a part. So I'm gonna edit this part directly as well. Edit sketch. Okay, here you can also see the geometry of the holes, right? So first is this one. Just drag it a random number. Okay, and then use smart dimension for the first one. Let it to be 3 millimeters as well. And then use equal this one and this one and this one should be equal. Okay, and another set is here. So gonna drill the holes again. And then the same, we can select all of them. To be equal. Okay, and exit, exit. So it will be like this. Right now we have all the holes, right? And finally, one last step is put the screws. So for this theoretical model, I think we're gonna use all the same screws, right? So let me insert hardware and choose, okay, M3 times 10. This should be fine. Okay, choose this and right here. So we're gonna use this size of screw to do all the positions. Okay, first we can do this position. So I select this surface, use mate, and then select this cylinder surface as well. Pull that out. Where's the screw? Okay, so click OK. Pull that out. And then choose this surface. Choose the surface on the bearing. Okay, that's actually a little bit short. Um, well, let's don't do this. So I'm gonna delete this. But let me measure the distance. So between this surface and this surface, the distance is 23 millimeters about. Okay, so what we need right here is 25 one. Okay, this should be good. And then do the same thing. Make this here, drag this out, make this with here. Okay, that looks nice. And then insert some 10 millimeter screws. We still need them because we need that a lot actually. So I'm gonna do this. Make this surface with here. Click OK. Pull that out. Make this surface with here. Flip it. Okay, that doesn't work. Then what we need to do is revert this one. Okay, and then choose this surface, this surface. Click OK. Okay, this one is down. Let me see. Change it to transparency. Change this to transparency as well. Okay, this one looks good. Do we have longer screws? How about this 18? Not sure. Okay, let me redo this first. Let me try this longer one. A little bit longer. No. So let's just use this 10 millimeters. Okay, for all the nut strip. Okay, after this, what I'm gonna do is right click this screw we're using and then choose copy with mates. So right now we can use this copy of mates because we're not doing the hinge mate again. So that's pretty easy. Choose this surface, and click OK. This surface, again, click OK. All right, and for now, this surface, revert it, this surface. This surface, revert it, this surface. Also this one. Oh, it can be done directly. Okay, that's good. And then we need to put those holes as well. So this surface, this surface. This one, this one. Wait, this one. Wait, this doesn't seem correct. Okay, let me mate this surface with this surface. Okay, that's not correct. Revert this one. Then this surface with this surface. Okay. I'm gonna copy this part with mate. So will be the same. Uh, Let me see where else I need those screws. Oh, I need screws for the gears as well. So let me do this. Make this transparent and then do the gears. So this one, copy with mates. Next, then this hole, this surface. This hole, oh wait, this hole, this surface. Also this hole, this surface. So when you finish when you finish one component, you can push enter. So it will goes to the next component directly. It will be faster. Oh wait. Oh wait. No, I did something wrong. What do I do? Okay, this one is correct. Then this surface made with this surface. Okay. Just copy that again. All right, so we finished the gear part. Then let me see what else. We're missing the, okay, we're missing the screws for this input link and the hubs. So I'm gonna do this right now. Oh, and also all the joints. And let me do it one by one. So for those ones, I think I can still use this M3 times 10. Let me copy with mate. Okay. Okay, we just need three of them, right? For this one. Actually, let me put this screw on the other side. Let me delete this. Let me make this transparent again. Copy with mates. Go to next. Then we can make it this side actually. Yeah. So 1, 2, 3. Okay, looks good. And then here, 1, 2, 3. Okay, nice. Um, here as well. Okay, this is too short actually. So for those one, it's better for us to change the length of the screw. Let me see. So we will need this length, 25 one. Okay, copy with mates. And then just do the same thing. Oh, we need a D shaft here, another D shaft. So I'm gonna add the D shaft again. Okay, that looks good. Let me see. For those ones, I think it's better for me to, well, let me measure the distance first. 14 millimeters. So I think we have some screws that is 15, right? 18. That should work. Let me try this. Um, let me delete. Let me delete this one for now. Okay, and then let me put that in. Mate to here, and then mate this to here. Okay, almost have the interferences with the gear. No, let's actually don't use it. Let's use the short version. Yeah, so let's keep it like this way. But the thing is, when you guys do the real prototype, so make sure your screw can be fixed for those parts. Like it should be long enough. So what I'm missing here, let me see. Oh, okay, so I will need to put another screw right here. Let me copy this, copy with mates, and then here, here. Okay, let me see. Okay, everything looks good. So I'm gonna need another D shaft for here. Drag the D shaft and then make this one concentric. Okay, and then this to this surface. Okay. No. So this is not lined up. Let me see. Where's the mate? Right here. Okay, let me change this mate. I'm gonna change this mate to the width mate. So it will be on the center of this two surface. Choose these two surface. Okay, just move a little bit. And let me see. Okay, the nuts. That's the last thing. Where's the nuts? Nuts, nuts, nuts. Here. Okay, great. Okay, choose this edge. This edge. Mate. It will mate to, we can mate it to this cylinder as well. Actually, oh wait, let me do this. So do this one first. Choose the surface right here. Click OK. Drag this out. Okay, put it back, and then make this surface with this one. Okay, and then just do the same thing. Copy this with mates. So we will need here this surface and this surface. Okay, and where else? What else we need? Here, another one. Okay. Okay, and then change the transparency again and do the last two mates. Okay, we're missing the screw right here, so let me measure the distance first. Here to this surface is 52 millimeters. So let me find 52. We can use this 50, I think. Just use this 50. So right here, and then made it. Okay, this one is a little bit short as well. So that's okay for the theoretical model, but make sure if you guys are doing the prototype, you will need a longer screw for this kind of joint. So right now the model is ready to do the motion analysis. Um, and before doing the motion analysis, we are still missing one mate, which is the mate between this gear and the input link. Can see when I rotate this gear, the input link doesn't rotate. So the best way to have this mate, like between this gear and the input link, is to form a subassembly for this input crankshaft. Um, we can also make a gear mate between this gear and the input link, but then when you go to the motion analysis, it probably will have some error because we have a lot of parts and a lot of mates right now. So to avoid this kind of situation, I highly recommend you guys to just use the subassembly, just like I showed how to do it in Halloween Walker. And this structure is much simpler than the Halloween Walker, so it doesn't take that long, and you will have the motion analysis down without any errors. I'm pretty much sure if you do the motion analysis, if you do the subassembly. So that's it for the SolidWorks model construction. Thank you.